So let's do example 1. Determine an equation of this graph of a quadratic formula. And what we're talking about here, let's just refer to this as y equals g of x. It's going to be really good that you get comfortable with this sort of thing. Y equals g at x. It just means y is some function and we don't quite know what the formula is yet. Not the formula, sorry, what the equation is yet. Let's just write down the quadratic formula in the vertex form. So if I would say y equals ax minus p squared plus q. Remember, even though in the summary what we did was we took it apart and talked about 3 different sort of functions. Remember, A is our stretch or compression factor, which is vertical. P is just our x-coordinate of our vertex, and Q is the x-coordinate of, is the y-coordinate of our vertex. So what we first should probably identify is what this vertex is. Be careful, each one of these tick marks up and down go down 2, but each one of these is 1. So this vertex point here is actually, I'm going to write it a little bit bigger. It's 4, negative 2, not 4, negative 1. Always pay attention to your scale. Since we know what the vertex is, we know what P is, and we know what Q is. So let's fill that in. Y equals A x minus 4 squared minus 2. Negative 2, negative 2, this is the tricky bit. Positive 4, minus 4. Okay? So the Q's are the same, but those X's are going to be different. Okay, great, you say. Now what? We don't know what A is. A could be 1. A cannot be 0 though, remember, because then that would make it so that it's not a quadratic. Then it would just be a constant function. So how do we want to solve for this A? Well, what we do is we pick a different point and substitute it into this equation here, and then solve for A. Because right now we have 1, 2, 3 letters. If we substitute in for x and y, then we'll just have one equation, one unknown. We can solve for that. All right, so I'm going to pick another point here. This actually, do you know what? Let's not do this one. Let's do this one. This one's nicer. It's going to be oh shoot, do you know what? I drew this a little bit off. What I actually wanted this to do is go here. So then this point is actually 2, negative 14. Sorry about that, guys. This point right here is 2, negative 14. So this is our x value. Okay? This right here is our y value. And what we're going to do is we're going to substitute it in for our x and our y up here. So I'm going to say negative 14 equals A. Then our x is 2. 2 minus 4 squared minus 2. So all I've done in this step right here, I have substituted a known point. Always use known points, okay? Don't pick this one. I think this is, 3.2, 5. That's not very precise, and so your equation is not actually going to be that accurate. But since I actually gave these points, okay, since they've actually been dotted, we can look at them and tell from the graph exactly what they are. So now I'm just going to solve for A. So negative 14, Just making sure you guys can see here. Negative 14 equals a negative 2 squared minus 2. Negative 14 equals negative 2 squared is 4, so 4a minus 2. Add 2 to both sides. Negative 12 equals 4a. A equals negative 3. So now I can just take this, and I know that I will have a y and an x, but I don't want this a. I don't have to have that a anymore. So the final solution actually is y equals negative 3 x minus 4 squared minus 2. And if that doesn't actually come up, I'm just going to verbally give it to you. Y equals negative 3, open bracket, x minus 4, close bracket, squared, minus 2. So basically this exact same thing, but instead of a, we say negative 3. Why does that make sense? Look, a is negative 3. It means that it's opening down. Awesome. And it's actually a little stretched. Awesome, because we have a 3 out front here. We know that it has gone down 2, which makes sense, negative 2. And we know, and because the vertex is a point that we can always check, because we know in the mother function, it's always at 0, 0. So we know that it's gone down 2 and over 4. Gone down 2 and over to the right, 4. Perfect.